Okay, so let me present to you the O2 platform and mainly how I write unit tests. Let me just get an idea here. So from the guys who are here, which one of you says you are a pure developer? All right, cool. Which one of you guys actually are pure testers? Okay. Which ones of you actually write tests while you develop? All right, good. All right, and who's like security professionals who do kind of security stuff? All right, and what are the other guys? What did I miss? Well, are managers? Sorry? I write tests, cool. All right, so anybody know the O2 platform? Have you guys used it, play with it? All right, none? That's all right. So the O2 platform, right, is, in a way, is my history of trying to figure out how to scale security knowledge. Right? And if you guys are going to see the keynote I'm going to do at 5 o'clock, you get a much better picture of how that whole thing fits. And this is more about the technical kind of element of it. So the kind of O2 platform started as my research on actually a company called Ounce Labs, which became IBM AppScan. Like, who uses static analysis tools here? Fortify, Checkmarks, IBM AppScan, right? Cool. You like it? All right, which one? AppScan. AppScan Source. Hey, look at that. So I used to work for Ounce Labs, right? She got bought for that thing, right? And you use, what do you use, Fortify? All right, cool. So how many findings do you usually get?
We're trying to incorporate it into a 6-year-old code base.
Cool. Cool. So the interesting thing, right, and this will probably not make a lot of sense for the guys who haven't done static analysis, is the O2 platform started with me trying to make sense of 10,000 findings, right? Which kind of, I was the guy that got given like the, poof, there you go. Yeah, we can't show that to developers, right? Because that's kind of a bit too much. And I got to the point where I could automate myself, and I could automate so much that I actually was generating millions of findings, right? Because what I wanted was visibility, right? So the O2 platform started, it basically is the open source part of that, which is quite cool because when they changed directors, I was able to open source it. So I was able to actually save my research. So it's still there, right? And I still use it. It's still very powerful. I did an engagement finished last week, and it was still the best tool that we had to actually do assessments. And I'm going to show you some of the tricks I use doing that engagement. So it's basically a toolkit for automating application security, knowledge, and workflows, right? So, and this for me is the way you make application security scale, right? So what the biggest challenge we have is how do we take security knowledge that exists in somebody's brain or somebody's head and basically transfer it in a way that you actually can use it on a day-to-day basis. And one of the things I've done recently, I actually became a professional programmer for a while because I wanted to actually ship code. I actually want to have that responsibility. And I realized this is very key. It's absolutely key that we are able to capture security knowledge. And eventually, and you're going to see in the evolution, is what started has a whole bunch of tools, a whole bunch of techniques, a whole bunch of stuff to give you access and to automate your knowledge, ended up in tests. And that's why for me, tests and integration tests and unit tests or whatever you guys want to call it is fundamental. If you guys are not writing tests every day, you are doing it wrong. It's that simple. If you don't write a test for every single line of code you guys change, you are doing it wrong. It's that simple. Right? I've seen complete websites, global corporations being brought down by one line change. I had a warehouse, right? A warehouse, 3,000, basically packets waiting at the door that was basically on hold because of one character, one Chinese character in a particular address, right? And that's just extreme cases, but you have to capture everything you do. And this is kind of my approach to it. So when you start to use it, you can do a lot of great stuff. And this is something that if you guys do static analysis, you probably appreciate a little bit. What this is this is two stack traces, right? So one of the things that is also very interesting when you develop is, in a way, you don't have sometimes a lot of knowledge about what's going on your system. In fact, the more you test, the more you have that. So how many guys here develop and use the debugger? Right? You guys use the debugger? Okay. See, what's interesting is that when you use the debugger, what you're really saying is, I don't understand my code. I don't understand what happens there in my code. Actually, this might work. Cool. Yeah, what happens there? right? So what you do is you debug. You know, depends if you're on Visual Studio, F1, F11, blah, blah, blah. If you're on thing, F8, right? We still, actually, who has used here Ollie debug? Ah, there you go. You guys haven't used Ollie debug? Come on. I think it shows how old we are, right? So Ollie debug is an amazing C++ reverse engineering debugger, and had an amazing feature, which was auto trace. Remember that? Animate trace? And that simple thing makes a massive difference. It means that you can actually animate your debug, right? And Visual Studio tries to do a couple of interesting things later, and there's a couple of stuff, but it's funny how that little feature even just saves you from clicking F11 or F5 or whatever for long times. So what you have here is actually a trace from a website, a vulnerable SQL injection, that takes a user control, goes to this, hits the web services layer, jumps the air, because this is basically, you know, a web service call, hits on the other side, goes in here, calls some interfaces, gets like a SQL engine, blah, 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 and eventually hits the vulnerable point, right? So those are basic. So when you trace, you're doing that, right? That's what you do. Because your question is, I had a bug here, I don't know how to get there, let me start over there, and then let me go through. So one of the things I realized was that the more my test infrastructure become, the better we become, the less I needed to debug. And I got to the point where I now consider the bug actually a sign of technical debt. It's actually code smell. It means that as developers, you don't have enough time to actually figure out how to build systems to get to a particular location. And in fact, these days, I would say it's nothing to do with you developers, it's actually your managers, right, that are at fault, because they should be demanding that. But I have a couple of slides on my other presentation about 3 or 4 ways you need to sack your manager, right? Because if your boss is not asking you to do specific things, actually he's at fault, not you. In fact, if your boss is not asking, in fact, even to use tools that make you more productive, he's at fault, because he's making you guys 20% or 30% or even 50% more unproductive, right? So this trace here, in a way, is what you guys do when you debug. You start there, you go there, hit a web service. You know, if you're lucky, your debugger might allow you to jump that. Sometimes you can't, right? And this is even a simple example. What I can do with O2 is glue them together, right? So this was really cool. So I was actually able to programmatically create traces. You know, all your partial traces you have there, right? By the way, there's a couple of Fortify plugins to do that. And if you're using AppScan, man, you can still use this stuff, right? So this is a great way to grab 2 different services, 2 different traces, and glue them together. So it's kind of an example of stuff. So there's a bunch of things. I'll actually put the slides online so you guys can read this. O2 is basically a massive pile of script, right? It's my brain condensed over the last 5 years. Every time I had a problem, it's kind of like, ironically, it's almost like I did O2 before the NPM stuff came along, and then I kind of stopped developing a bit because I actually built like a package manager into O2 to put all the scripts I had, right? And I'll show you that. So what I want to show you first is actually today, because I think there's a very interesting correlation. So instead of showing the kind of .NET and some of the more crazy stuff in O2, I want to show you what my path as a developer and my path as a security professional, when I got to the idea that I need to write tests for everything, I need to automate everything I do, led me to, right? So I'm going to show you an example of, for example, starting WebStorm, right? So, okay, can anybody tell me what technology I'm using here, apart from WebStorm? Sorry? Correct. And else? What else is there at play? Can you tell me why I can do this? You guys know what's going on here? All right, so, okay, who programs in JavaScript here? All right, so you guys have to buy, and girls, sorry, you have to buy this tool, right? And if your boss doesn't buy him, you need to go to his boss and tell whoever is on the food chain, say, at the moment, because you don't want to spend 100 euros or whatever it costs in my environment, I am 20% more unproductive. And my code is much worse than it could be, and my code coverage sucks, right? And then what I'll do, I'll show you guys a nice, who uses Jira here, by the way? You guys use Jira? probably some of you guys use. So I'll show a nice little workflow in Jira to make sure that you have a nice, great button that says accept risk. And the risk is my code sucks because I don't have these tools, right? And you make your manager click on that thing, right? Maybe don't use the word sucks, but it's kind of equivalent, right? So what you have here is a tool called Wallaby, right? And what this tool does is this tool, in a way, this tool does what I had in O2. And I'll show you that in O2 platform. What I didn't have was the great integration with the IDE that I have here. So what I have is I have real-time code execution, right? And I have, what's it called? Real-time code coverage. So those two things make the whole difference. These two things are the difference between 100% or 98% code coverage and 30% code coverage. These are the difference between debugging and not debugging, right? This makes the whole difference. You code better, you code solid. You can write security stuff on top of it, and it's free because you build a test environment. You code like this, you realize that your test environment is much more valuable than your real code. I get to the point where I actually, when I look at the real code, the actual code that runs, what I really want is simplicity. I want understanding. I want to be able to go drunk, come back the next day, code, and actually that thing still makes sense, right? Because I have a nice path. I want to make sure that when I make a mistake in my real code, I know about it straight away. And that's the kind of stuff you can do in these kind of environments. So what I have here, you can see, and I want to show you some complex tests, because the point of this, and who has used Selenium here, by the way? You guys use Selenium? Do you love it? Come on, who loves Selenium here? All right, so by the way, Selenium is great. For me, Selenium has a cardinal sin, which is not native, right? So, and there's another massive problem with Selenium architectures, is that the Selenium environment doesn't tend to be used by the developers. So what you have is you have the developer guys over here, they code their stuff, they send it over the fence to the QA guys over there, which by definition you broke all their tests because you've done stuff, right? So those guys now have to keep maintaining this freaking pile of things, right? And they are very allergic to change. What we want is you to use, for example, Selenium. If you have Selenium, if your devs are not using it, you're doing it wrong. It's that simple. Because it means that what actually happens is you are able to automate your actions. Now, for the developers who click on stuff, right? Now, you need to imagine this, right? How much time of your life have you spent clicking on things? Right? How much time of your life have you spent making a code change, right? And if you're in Visual Studio, it's even worse because you have to freaking debug that thing, right? At least if you know Eclipse, it goes up automatically. Node and others, you get directly. But how much time of your life you spend literally going code, browser, click, click, click. And now these days is what's it called? The JSON thingy, the plugin. Sorry? No. The one to send REST requests. Postman, there you go. Everybody has freaking Postman, right? I even seen guys who have scripts for Postman, which is great, but that's not a freaking unit test, right? And then I've seen guys who've done some crazy stuff with SOAP UI, right? And I'm thinking, that's great, but actually you just are writing tests, and now you create another totally unmaintained code base, right? So basically, you need to get to this mode where the developers, on a day-to-day, use this stuff. They see it in real time, right? And this is the key. This is in a way, this is the way you do it. So I'm going to show you some cool examples of, for example, you could see how fast this is. Can you see that? Right? This is a game changer, right? What this is I'm actually calling a particular method. So let me just make sure where I am, right? I'm calling, for example, a service where I'm grabbing a service and I'm adding, for example, a breadcrumb, and I'm confirming my current breadcrumb, depending on what I add, is there, right? So I go like this. Now, one of the things that's really cool about this, actually, you can even see, I need to do it right. There you go, right? You can see it passed, or it should pass, or else I am not doing something right here, right? And, oh, cool. Actually, see what I mean? So in fact, I can see where it passed, because I should have changed here too. And there you go, right? I cannot, okay, first of all, I'm going to spoil you because Wallaby is actually, it's ridiculously fast, right? It's actually the point where I have a screenshot of, I was actually typing a unit test where I was creating a bunch of folders and then checking if it was deleted. I had 25 folders created where I can actually see the characters that I was typing because it was literally creating the folders in between my typing, right? So by the time I added a test to delete, I already had 20 folders created, which is basically how fast the thing is. I'm going to show you NCrunch. Anybody who does .NET here? Anybody doing .NET? All right. So if you guys are doing .NET, you have NCrunch, right? Which is the equivalent. And you cannot code without it. I'm sure you guys in .NET use ReSharper, right? So NCrunch for me is even better, right? If I have to trade one, I use NCrunch, right? But having both is even better, right? So, and if you're Java, you're a bit screwed, right? It's not that bad because if you use IntelliJ, there's some stuff you can do in real time. If you do Eclipse, I'll show you how you can actually program Eclipse in real time. So there's some cool stuff in there. But the two best ones are actually NCrunch and Wallaby, which I'm starting here, right? So you can see that, I'm doing this. But the other thing that's really cool, and this is what I'm saying that you don't debug, is if I go like this, right? I can actually now start to see the paths, right, that actually hit the application. So I can actually, for example, start to really understand, actually, breadcrumb service, here we go. Like, I cannot underestimate, whatever the word is, right? I cannot tell you guys how powerful it is to be able to code in an environment where you have this. Okay, where's the other guy? Where did he go? Test. All right, so when I code like this, right? I basically code on the left, code on the right. So I think one of the big disservice the test-driven development done to the industry is this idea that you write this very big test and it fails, and then you go and fix it, and then you do some stuff, and it's all about the failing test. It's all about this very negative thing. For me, right, and this is kind of like, you might break your head a little bit if you guys do a lot of testing, is my tests always pass, right? My tests pass 100% of the time. The only difference is what I consider that test to be. So if that test, for example, is exploiting a security vulnerability, that test will pass when that vulnerability is there, because the vulnerability is a feature. If you have SQL injection on your application, you have a feature, which is I can control your database remotely, right? That is a feature. That is a known behavior, or hopefully not known by the attackers, right? But that is a behavior of the application. If you have cross-site scripting, it means I can put HTML on a page. In fact, I can control your session. How cool is that? That's a really cool feature, right? I can edit your content, right, remotely, right? That's nice, right? That's a feature. So you want a test that pass when that feature exists. What you do is you put on different namespaces, so you know what that means, right? Or you put on different projects, even better, right? And then you have a regression test in the end. That's the flow. So what you do is, I have this really cool concept where I find what I do is I pair program with myself, right? So what I do is I go here and says, okay, imagine I did wanted AAA. Imagine I want AAA and title, right? Let's say I actually wanted, so the scenario here is that I want every title to have L title, right? For whatever reason, right? So I could come in here and says, okay, this would actually be one where I go, I do actually want L title. So I can come in here and I can add it, L title, right? So now the test should, underscore, right? And the test should now, hopefully, title, query title, actually, here you go, it passed. In fact, you could see, can you see what happened, right? It actually passed, can you see that there, right? It's actually already correct. And here's another interesting property that I found. One of the things that we also don't like a lot is the idea that you do one assert per test, right? For me, you want your test to be as solid as possible. You want your test to give you this really nice padded path from A to B. So in this case, for example, the fact that I'm doing multiple tests actually allows me to have more assurance of what's going on. And if you have something where a lot of people say, yeah, but then you have these tests where you spend a lot of time fixing the tests instead of fixing the code, then it means your tests are wrong. Then you need to refactor your tests. Your tests are not some back of the envelope, some amateur stuff that you throw around. In fact, for me, your tests are more valuable than the real code, right? Your test is what makes sure that when the real developer or the original developer leaves, the next guy actually can make decent changes, versus the next guy going, whoa, I don't understand how this thing works, right? And then you got all these bug requests coming through, and the guy goes like, yeah, okay. And it might look as it's a very small change, but I don't have the balls to make that change this week, right? Because I'm still understanding how the code works, right? Which is ridiculous, right? Because if he's the Chuck Norris of coding, right, and he's not that experienced, both of them, or as a good professional, but let's say not his level, they should be able to code at the same speed. Because even the Chuck Norris guy, in the first week or first hour, is going to be as bad as him. In fact, the only difference I found is the Chuck Norris guy, or the really good programmer, he will say, you know what? I know what I don't know. So actually, let me think about this. fact, the worst programmer or the worst person is the person who has so confident they don't understand their own limitations, right? They go, yeah, I'll do it, no problem, right? And then fucking the whole thing explodes, right? So, so you can see here the power of being able to modify things, right, in real time. The power to be able to program, right? And you do get your green thing, right? And again, I get a nice feedback here. So what's the problem? I expected that array, and I can even confirm here, and then I can go in here, and then if I'm not annoyed, there you go, that passed that thing. But now I can turn around and I can say, let's say I want another thing, right? So this is what I mean by pair programming. So the way I look at it is you always code with your test, always, right? You code and you have your tests. So that means you get to the point where you make no code changes, that you don't change your test. And this is for everything. In application, we got to the point where we actually had tests for CSS. We actually had tests for full-blown JavaScript. And actually, it's not because initially we actually thought it would be a joke, but it got to the time where we're like, actually, we can test that. Actually, it's not that bad. Actually, I want to test because there's a property that is only set on the CSS. So actually, I do need to test it. And then when you go to the back end, we have tests that spin off things. I'm going to show some cool stuff where you can do some magic foo in .NET. But sometimes it's needed to do that kind of stuff to access the back end. But all these things make you more productive, right? So so here's a good example. So if I want to go, I need a new path. Well, let's say I want a target here, right? See, what's interesting about this is that failed, right? So this is the key, right? It passes, right? And that's actually because there's another test. See what's cool about this? See, this test is actually covered by multiple things. See, one of the things that's interesting is after a while, especially because that's such a big thing, it's actually such a popular, in a way, feature, that you can see that I can now introduce something which is actually quite dramatic, right, in a way, modify the way the title is particularly created without a whole bunch of my tests failing. So and let me just fix this, and now this guy's going to pass, and there you go, that guy passed. And now I add my target, and that guy failed. And can you see how I don't need to debug? I know exactly where my test failed, right? This makes the whole difference. And basically, what it means is now I can come in here, and you can see now the bit, it says that particular guy didn't match the other one, and this is cool because it's all nodes, it's all native. So you can see I'm actually, in this case, I'm actually flying native. So I can go target, and if I go like this, that test passes. And of course, this guy failed because there's actually other tests. So one of the things that's interesting is I would expect to see all the fixes for my particular code change. And what's interesting is you start to get a very good feel for the tests that fail, for how damaging or how important that particular code change was, right? And that makes the whole difference. But okay, so these are like Mickey Mouse changes, right? So this is kind of not that interesting. So one of the other things you can do is you can also, for example, do this with web automation. So one of the things you can do, and by the way, so I always have two setups. I have a setup where I use Wallaby, that gives me the real time, and I always run it also, for example, with something like Angular, or with, what's it called? With, where are you? Come on. With Karma, because that's the one that will run on the continuous deployment. So you always have the kind of the real-time crazy stuff in Wallaby, and then you have the other one, which either use Mocker, or Thingy, or Karma, and that's actually the one that runs in the continuous deployment environment. So one of the things that's really cool from the continuous deployment is, for example, tests like this. So let me show you a really cool test, and is the QA tests. And this is using a variation of, what's it called? Of, where are you? Right? This is using a variation of Selenium, but what this is using is actually a much nicer thing where I'm actually instrumenting Chrome. Do you guys know the project called Electron or NWR? Have you heard that? So this is the crazy project. Both of them do the same thing. It was these guys who had the epiphany to think, hold on, Chrome runs on V8, Node runs on V8. Hey, can we freaking put the two things together, right? So they did some food, they got some, what's it called, the event loop got synchronized, so you can. So this thing at the right here is actually host basically Node and Chrome in the same process. So what's really cool at that is I was able to create a really nice bridge from here to there, where I actually now can program this kind of stuff in real time and actually see my tests running on the right. See, this is what I mean, that what you want, even when you're doing basically complex UI stuff, right, you can still have this real-time code execution and tests that actually will confirm, for example, what the hell is going on the pages. So you can see, and what you do is you build a DSL like this. See, page, user main, go here, put that, create, log in. So you create a kind of a domain-specific language to allow you to go to a specific place, right? So in this application, we have from the pure unit tests to the tests that actually instrument all the application without any mocking, to the tests that create some. In fact, I don't like mocks anymore. I think mocks are evil in a lot of ways, right? Basically, what you really want is to run the real thing, right? Ideally, the real thing with no state. So that's where Docker really comes into play. So, and if you mock a service, like a replayer. You don't actually mock stuff, right? Again, mock is just almost like code smell, because it means that you actually don't really control your stuff, and you have to come up with, these crazy things. And there's people, and then it gets silly when you mock the mock, right? Then it gets really funny, right? And you can see that you have the problem that you make a change and you have to change your mock, right? Actually, that's a bit over the top, right? So what I like about this is I can go from there all the way to what you call more pure integration tests, so sorry, more end-to-end, and then all the way to end-to-end tests, and it's still the same technology. It's still the same kind of workflow, right? So this makes a massive difference, and you guys really have to get your head around this, right? Any questions on this? So this is actually Node.js on the kind of a, in fact, there's a bunch of tests in here that are actually hitting a .NET web service, right? And these days, I would argue that if you do anything that is test over the network, either HTTP or browser, you should be using Node.js because it's a much better platform. And all you have to do is try to parse HTML or JSON in Java and .NET to really understand, why you should do that, right? Because you're fighting against the current, right? Because at least Node.js is native and it's fast. And when you get something like Wallaby, it's ridiculously fast, right? Okay, so now let's move into the kind of more O2 kind of world, right? So the O2 is a .NET application. Although, actually, one of the things you probably noticed that you guys noticed these kind of funny little methods here called, for example, assert is and this and .text and file.open. There's a whole bunch of stuff in here, which is actually an O2 project called Fluent Node. So I actually already brought a lot of the kind of concepts into Node, into there, right? So what I want to show you is, actually, I think I might have opened the wrong image, VM. So I want to show you what I do with O2 Platform. So the O2 Platform is kind of where this kind of hosting starts, and it's still a hell of a toolkit in here. Although I think I just opened the wrong image, so let me just pause that, and I come back to it in a second. All right, cool. Here we go. So, all right, so the O2 Platform is a kind of, it's a Windows application, it's a .NET application. It has, and it's basically, it's the fundamental concept of it. It's a REPL, right? So the REPL is read, eval, loop, print, which is the kind of what I was doing there. Is the idea is that you type something, and then it executes, and you see the feedback out of it, right? So the things, that might be far too small, right? Oh, okay, cool. There you go. All right. So the main thing about O2 is that it has a whole pile of tools. It has a whole pile of environments, and the things that you can do with O2 is, for example, something like this, right? So let me show you this really cool thing here. So this is a .NET application which has, and actually, let me just make it full screen, right? All right. So this is one of the scripts. In fact, this is a script. So it's all .NET stuff, right? So this is, at the left here, you have the different files. So you can see, here's a web service, right? Which basically, you get to see the web methods, and he calls the post message, right, on the data factory. So you hit the data factory, and there's the methods, there's the stuff, and this calls the SQL Server Engine. And then the SQL Server Engine calls this guy, right, a bunch of methods here, and eventually they call execute query, right? So one of the things that is very interesting is you could see that I have 3 different files, but I actually want not to read them in 3 different files, because what I really want is a slice of this guy, a slice of that guy, and a slice of this guy, right? So one of the things that you have with your O2 Platform is you can actually have this tool called MetaStreams Creator, where if you pick, for example, let's say this guy, delete, I get these methods. Now, can you guys see what I have here? Can you guys spot, wait, where is it? Make it down, come on. All right, can you guys see what I actually have on this particular file? Right? So you can see, here is my delete method, right? This is my web service. The delete method calls the delete message, right? So delete message. They call the data factory, which is here, right? And then this guy is going to call the SQL Server Engine execute command, which is there, right? And then that guy is going to call this one, which is actually here. So what you have is what I call a method stream. You have one file that contains all the source code from the first method. So if you're doing code review, this saves you a ridiculous amount of time. And it also allows you to understand what actually is going on the application, right? So what you have here is, if I pick, I think there's a more juicy one on user management, is you can actually see, in this case, you actually will see the SQL injection, right? So you actually will see the SQL injection on this thing, because I can actually I even can pick it up the methods. So you can actually see the, where is it? And so I pick up, there you go. So there's my parameter ID. And so there's my session ID. Actually, this is probably not the best one. Nah, let me pick a better one. This is not that deep. Let's say login. Okay, cool. So there you go. So you can see that what I have here is I basically have the methods, and I'm going to pick, there you go. All right. So what you have now, if you look at this, you've got my login methods, and there's even static analysis here, right? So this is, the irony is, this is like almost like a cheap version of the static analysis engine, right? So you can see that, and this is what, in a way, what the difference between this and the 45s and the IBMs is they actually scale, and in a lot of ways. This you actually need to customize a bit, although I do think that you get better results sometimes when you're reviewing than the whole pile of stuff you get from the other tools, right? But they do scan much deeper, right? But this is what they create. So on the right here, you actually have the taint flow. So you can see, starts there, goes into a parameter, goes to identifier, goes there, gets concatenated. Here is the SQL injection, right? And that way. Then he goes here, goes there, keeps flowing, and eventually he hits the execute command, which is actually here. So that is the vulnerability, right? And that's what you want. In fact, that's why you're doing the security analysis. But it's absolutely crazy valuable when you actually create something like this, right? Now, the thing about this is you don't create this by pressing a button. Well, to be honest, you can actually drag and drop and it will give you the first pass. What you will need to do is you'll need to customize it, because there's always things that are unique about an application. There's always validation. There's always other stuff. So there's a bit of sometimes customization you need to do. The difference is you come up with really powerful environments to actually do this kind of stuff, right? Any questions on this? All right. So this is very powerful. And now the thing about this is in a way is what you can create with the O2 platform, which is all open source, by the way. Everything I showed you, okay, apart from Wallaby, that's not open source, but all this stuff is open source, right? So the interesting thing, right? So the things I can do with, and by the way, this is a really cool tool. If you guys haven't seen, let me just show you this. So this is Hack Me Bank, right? This is a vulnerable Hack Me Bank application. So there's SQL injection. So you can go in here and you can see, oh, hello, I got SQL. Come on. All right. What happened? Is my Visual Studio not working? Crashed? No? All right. Should we get there? Cool. All right. So this is basically typical SQL injection, right? And great. Cool. There you go. So this is actually the worst case scenario of SQL injection. Well, not the worst. The worst is when you say, hey, can you replicate over there, right? Then the whole database goes, right? But if you get SQL injection and you get the data back with no control errors, you can literally do something like this, which is pretty cool, where this is basically SQL injection kind of database explorer, where I'm now going to browse the database server remotely from SQL injection, right? And you can see the queries underneath, right? So you can see that what I'm doing is I'm basically using and1 in select top min name from master, where name bigger than this. So I'm kind of using that query for every result to actually give me the next value. There's a more efficient way to do this because you can actually concatenate that in a bunch of XML files, but you get the point, right? And then I can get all the tables. There's the tables. Then I'm going to get all the values. So in fact, there's a tool I can't remember the name, but I have a screenshot in my presentation later on, which also does this with a better little UI. What's it called? Which is blind. So use blind SQL injection to actually get the same data. But one of the things that's very powerful about this, and you shouldn't underestimate this, is when you find a vulnerability, the last thing you want to do is patch it, right? Initially, you want to actually sometimes create a nice little proof of concept, show that to a bunch of managers, so they really understand the implications of it. If you patch it, you lose the opportunity. So actually, who here has a security team in their company? All right, cool. So the guys who don't, you are totally screwed, right? It's that simple, right? If you don't have an application security team in your company, you will have, lots of security vulnerabilities on your application. That's kind of like, and if you don't want, I'm sure there's plenty of companies in Italy that will take you on a bet, right? If you pay them really well and say, prove me I have problems, right? And The good news is not being attacked, because that's why you don't have, right, an application security team. The bottom line is you have no idea what's going to hit you next, right? So this is a good example of the kind of stuff they want to do, and it's a good example of the kind of power that a vulnerability can actually do to extract. Because now we're talking about real data. We're talking about extracting real information, real stuff from the actual databases, right, from there. Now, one of the things that's interesting is this is a .NET application, right? So let me ask you a question. So one of the things that is interesting on when you look at, for example, an application or web service is to understand the attack surface, right? You need to understand your attack surface, because or else you don't know what you're defending. It's like somebody says, make my building secure. If you don't even know what doors you have, you're not even playing the game. Okay, that's just the first question, but at least know what doors you have, right? So, okay, who writes a web service here, right? I'm sure you guys do, right? So you write a web service. So when you add a new endpoint, right, do you have any test that fails? Do you? How does that work? Cool. But when you add a...
It's not a team.
Yeah.
It's not a security.
All right, cool. No, so my point is that when you add a new web service, do you have a test that fails at that moment in time?
Before implementing.
Sorry? No, you implement the test, right? You add a new you implement a new feature, you add a new endpoint, you add a new web page or something, new controller, right? When you commit that, assume as you have no bugs on that thing, right? Do you have anything that tells you that your attack surface changed?
That work is done by the person.
Okay.
So I don't know.
Okay.
I have just a feedback.
Well, so at least the good news is you already seem to have a way to automatically and programmatically generate the attack surface, which is key, right? What you need to do is you need to hard code it, right? And the reason is because if Mateo over there, right, is responsible for security, right, and reviewing the code changes, and you guys have 20 developers here, or 5 developers, even 2 developers, he doesn't have the time to review every code. The only thing you can do is review and analyze the code that matters from a security point of view. So it's critical that you have systems in place that when the attack surface changes, you need early warning signs. You need tests that failed, so they need to be modified. So you know that when this test here was modified, that modification is telling me what the attack surface is, right? So if you look at it and let's say the attack surface was changed because you added a new method that takes an int, then you go, you know what, fine, that's it, job done, I don't care. At least from an injection point of view. If it takes a string, then you have a problem. Because what the hell is going to happen on the other side, right? And by the way, as developers, you guys should ban strings, right? Strings are evil because they're never what you think it is, right? You have no string in your application that's supposed to take 4 gigabytes of data, the whole Unicode characters, and everything in the kitchen sink, right? That doesn't exist, right? So strings are very evil, especially when you move to Node and Python and all those languages, which is even worse because the freaking string can become all sorts of crazy stuff, right? But even in Java and .NET and strongly typed languages, you want to have strongly typed objects, classes that represent something. It's an address. It's a type, it's something, it's a username, it's a postcode, in fact, that's why GUIDs are great, or UIDs, because they don't have that stuff. All right, so now we have this. So one of the big problems I always had was, how do I, for example, create that environment? So what I want to do is this. So I got the source code here, right? So where's the source code for my bank? There. So here's the source code for the application. What I want, right, is I want to create a tool, and this is, the reason the tool is important is because the tool is something that you will give to the developers so they can start to use and maintain, and what they're going to be doing is maintaining the QA API that you're going to use as security. See? So my game is to say, I need these tools, I need these APIs to do my job, because if I don't have good, solid QA APIs, like when you say that I have something to calculate automatically, I go, great, because I can use that, because you already saved me from having to create it, right? So the logic is, you create these tools, you give them to the devs, you give to the QAs, they are very happy with it because suddenly they're more productive, they maintain that stuff, you get your API, on the back of it, you add from a security point of view, you add the abuse cases. So you get, in a way, the developers also get the abuse cases for free because they are now compatible with your API. But so how do we kickstart this? So here's what I want to do, right? I want to create a tool that is going to take this folder here, right? And let's say drag and drop, or just take a folder. I want to show all my ASPX pages, right? and my web services on the left, right? And I want to click on it, and I want to see that, and when I click, and I want to see that at the top, right? Actually, I don't have a thing here, right? No, this is too. Oh, okay, cool. All right. So what I want to do is I want to create a tool that basically here is going to show me all the files, the attack surface, right? And here, when I click on it, it's going to show me the browser. And then when I click here, I want to see the source code. And just for our thing, let's see the source code.cs, because a lot of times there's code behind on it, right? And then just to make it a bit more interesting, I want to add a menu at the top that allows me to log in as multiple users. So I can actually say, log out, log in as user A, log in as user B, and see what's going on here. Then if you want to be more cool about it, you can actually start to automate this whole process, so you can run the whole thing and create a nice table that shows you for user A, user B, user C, for page 1, 2, 3, 4, this guy can see this guy can see that, and then we can do a proper authorization analysis. Do you guys understand the power of these tools? This allows you to navigate to any page straight away, log in as any user. Eventually you start to add stuff to actually go to particular things on business logic, right? This allows you to programmatically create the authorization rules for the application, right? How long will it take you guys to develop this? Sorry? 1 year. 1 year? Come on. Nah. Sorry? All right, you guys are a bit slow in Italy, man. Come on. No, I very much doubt that. I very much doubt that if you got given this brief, right, most of you guys are good developers, within a couple of weeks, .NET or probably, Python or Eclipse will pick that, right? You can do it, right? Now, what you have to understand, right, and this is where you have to have, who does security assessments here for a living? Who does security reviews? Okay, Matteo. Who else does that? Anybody? Only him? All right. So you do the same thing? Cool. So his job, now you have to imagine his pain, right? How long did it take to develop your application that you're working on at the moment? Right? How long? 5 years? 20 years? Okay. How many lines of code? How many lines of code? 2 million? You don't even know. This is interesting, right? So he gets given, right? There it is, right? That application, if he's lucky, he's going to get 2 weeks. Most likely, he's going to get a week. Correct? To the application. Correct. And in that time, he has to freaking first run the thing, which usually tends to be a freaking problem, right? So Monday is get the thing to work, right? To get the setup environment. Then he has 2 days to get in his head everything that you guys have. And he has to keep finding stuff, and then he has to write a freaking report on it, right? So one of the things that now he needs this tool. Can you see how valuable this tool is? Like the cool thing is when you take an application that has been security tested, by the time you finish this tool, you're just documenting vulnerabilities, right? Because you're going to have a massive attack surface there that was never properly tested. So there's going to be a huge amount of functions that if you call, you now run codes as admins, and I'm just logged in as a user A. The problem with these kind of tools is that okay, a year is a bit too much, right? But even 2 weeks, right? Even a week. He can't spend. Can you imagine you going to his boss going, hey, man, this is great. Do you mind if I spend like a week building tools to analyze the application? It is not going to happen, right? So the thing about this is you need to be able to write this in hours. In fact, you need to be able to write this in minutes, right? Which is I'm going to show you now in O2. And after that, I'm going to show you a bug that we had on the other application that was crazily nasty, that was a massive denial of service, that we caught on that Thursday where we're supposed to have launched the previous week, right? And you know what the drill, freaking ship it, right? And there's no way at that moment in time that I was able to understand exactly what happened if I didn't have that tool, right? So what you have in the O2 platform is you have a pile of tools, right? And there's a whole bazillions of scripts that I've wrote and blog posts and stuff, and you can find it here. Right? And even, it's just actually, one of my favorites is this one here, right? So even like a little search engine, I'll show you on the other one because I think I'm actually running an older version here. But I'll show you that search engine in a second. All right, so I'm going to show you, so this is the main functionality of O2. So this is called a REPL, right? A REPL is basically something that you basically type something, execute, and you see the feedback. So you can see I put 12 there, I go here, I can execute it. I put hello world there, I put there, right? And it executes there, right? Can you guys see? So this is that kind of feedback. Now, for me, one of the key things when you're developing is you want this world where you lift your hands and code executes, right? And the way I look at it, right, and this might sound a bit weird, but if your boss, right, your business manager and your CTO is not demanding that you figure out how to do that, that's his problem. He's wrong, right? And you need to have the balls to start telling him that you're on the wrong side of history, right? And if you guys are able to get your head how then to do this, there's some great jobs out there. A lot of teams that will hire you straight away once you get into that mode of development, right? So in this case, I did that with O2 Platform, which as you can see now is what I also get on the other side. So if you go to here, execute options, and you enabled on compile, you can see that now I can lift my hands and the code executes, right? Can you see that? So that means, and I look at the psychology of this, right? That means that in your brain, you have one thread. And I know women have more than one thread, and the guys have one thread, and I think that's actually pretty well established, right? And for the guys who are married and kids, you've learned to accept that as reality, right? And basically, and the reason it's bad is that we are really bad at changing context. Right? We are really bad at doing something and then figuring out in your head, what do I need to do to get that feedback? Right? Because you guys write tests all the time, but your test is a manual. Your test is move the mouse, go here, do this. Fire Postman, go to the browser, do some stuff, right? That's a test, but it leaves nothing behind. So what I have here is I have those test environments. So let's come up with this. So basically what you have here is a whole bunch of APIs. So you can see at the top, so I'll show you some of the things. So what I have here is the top panel, which is this guy here, which is, I can now add stuff to it. So I could say, oh, I want a button, right? Let's say I want a button, right? And I want the button to say, hello. And so now here's my button, right? See there? There's my button. Let's say I want the thing to be on the whole screen. So I go fill, right? And now I have the whole thing. And now when I click on it, when I click on it, I say, after select, or on click or something, there you go, right? I have a nice little callback, right? And then this can say, you clicked me, and then you kind of want to do an alert, and then you can see here, there you go, you clicked me, right? And actually you can even just go one step further and go click, right? So now it clicks straight away without you even having to lift your hand. There you go. Right? Now, those things are extension methods, right? But those are APIs. That's a DSL. That is a domain-specific language, which is the other thing you guys need to get your heads around, right? Those things are fundamental because that means that you can create APIs that are very clean. They're very effective. They make you productive. And they also allow you to refactor a lot. Okay, so that's not very interesting. What we really want here is I want to add to my top panel, I want to add a tree view. Right? So I'm going to add a tree view here. And by the way, you can do all this stuff in Visual Studio also. And this is actually called Fluent Sharp. These APIs I'm coding here, right? And now I'm going to go, I can add a node. You can see, so you can see I just added a node there, right? You can add more than one node. That will add the subnodes, right? And there's also this thing called Fluent API where it kind of returns what you expect it to be, right? So when I add a node, it returns the node itself, right? So now we're going to add the first part of our thing. So I go here, and I'm going to say, I'm going to take the source code. So I'm going to put that on the file, var path equals the source code. And now I'm going to add to my tree view, I'm going to add nodes with my path. And this, see, files. See, the point of this is this is the thing I never understand with API designer. I want a freaking file, right? I don't want 20 lines of code. I don't want 10 lines of code. This is why Python was so successful. This is why Node in the way is so successful. You look at Java, right, and .NET, and this massive salad of functions. I'm like, dude, I want one thing, right? I have a particular business requirement. Yes, error handled inside of it, but give me clean APIs. Like this, I have a path, I want files, right? You can get drunk, come back the next day, it's still going to be called file. You need to be really drunk to want a file and not call that function files, right? So, it works well. This is exactly the kind of API. So now you can see I got my files. But actually, maybe you actually want to get the file name on it. So you can go for each var file in files, and now I'm going to add, a node, so I'm shifting between things. So I'm going to go files doesn't exist. Oh, correct. So because the files doesn't exist, so I got there. Now I'm going to add my file. Actually, I want my file name. Actually, I want to remove the path because it's actually cleaner for, what's it called? Where's my path? There. So I'm going to remove my path. So I'm going to go file, remove, path, and so now you can see that it's going to go there. Oh, add nodes. Okay. There you go. So there's my guy. Actually, I want a recursive search. So actually, let's go recursive search. I actually only want my CS files. So I want .star.cs, and I want star.astx, and I want, actually no, ASPX, or actually, sorry, wrong, ASPX, and I want the ASMX, star.asmx, there you go. So now you can see, there's my ASP.NET files, there's my things, and there's my thing. Actually, you don't see the ASMX because I actually need to go like this, and now there's my web services included, right? And a whole pile of other stuff, right? So you can see that now I got my first part of my thing. So now I got the bit where I can basically go in there, give a particular file, goes to the system, downloads the whole thing. Now the next part is I want to browse it to the right. Actually, I want to see the content. So what you can do is you can basically go, let's say I want a text editor, right? And then I'm going to go text editor, and I'm going to go tree view.add. So actually, I'm going to go insert right. And what this does is this is going to insert a little panel there. So just to show you red, right? There it is, right? So now I can go add text editor, right? And oh, actually text box, sorry, text area, right? And then I got it there. And oh, sorry, semicolon. So I've been programming in Node for too long these days, right? There you go. And then what I can do now is I can say, I go back to my tree view, and I can go and say, well, after select, and I can say I want a string callback, and then this is going to give me the file name, and then I'm actually going to go to my text area, and I'm going to basically add some text with my file name, right? So, and what I get now is, see, when I click on this guy, yeah, and I just need to put the path here, and now I should get, there you go, right? I got the path. So now what you just need is actually pass the whole file in here, and then put file.file contents, right? And then that should give me the file contents, right? Of whatever I'm opening here, right? And then if you want to browse at the top, you go var browser equals text area dot insert above, and then I go add web browser, right? And you can actually go, there you go, and that browser, just to show you, I could have gone, what's it called? Browser dot opened, and then I could basically open a website on it. Cool. All right. So there you go, and there's Google. Yeah, if I'm online. There you go. So the last thing you want to do with this is instead, and this is where you disable the auto execution, right? Is you come in here and you say, actually, I want a standalone tool. So you go like this, and now you can see that now is standalone tool, right? And then just to top it up, to make it really nice, you package this guy. Actually, there you go. And that basically, what he's going to do is going to actually create an executable, which is this one here, which actually, if you save it before, it would actually do the thing. So this would be util, view files, things like that. And now this is a standalone executable that you can click on it, and you get that. So you can actually put that somewhere, store that particular logic, that particular API, and that's now a tool that exists that does exactly what I said that can be deployed. So you can actually deploy these just with a script, so you can give that as a script to somebody, and that is great for things that you actually want to put as part of your build environment. Does that make sense? Can you guys see how I was going to write that? Okay, I don't have enough time, but you can see that I wasn't that far to do that, right? So let me show you where this saved, literally, my bacon, right? We were, and this is the bug, right? Let me quickly find it. And by the way, one of the things that's really cool is I actually was working for this company called Secure Innovation. And although the source code is not open source, we actually open the code. Because again, you don't want to play secure web obscurity, right? So all the code is open, although it's not open source, it's all public, which is great because I can show you, right? We had this really interesting bug, right? Which is basically, I think he's here. Okay, so we had a very interesting bug, which was, I think, Wikitext, right? And no, DOS, denial of service. So, oops. So basically, so so this is what happened, right? So I was saying that we were basically where we were doing that thing where we were about to ship, and yeah, sorry, I thought it was Wikitext. TM4 design. Oh, I'm actually. Whoa. I might actually be on. Yeah, it helps. It helps if you search in the right repo, right? Okay, and there you go, right? And okay, so what's really interesting about this is basically, and this is the important story, right? So the reason why you want to have these tools in your bag is because here's what happened. It's Thursday. We're already a bit late to ship. There's some pressure from the business to go, hey, come on, guys, get this over, right? Roman comes along, guys doing the QA stuff, saying, hey, I got one here, right? But it doesn't render very well, right? And basically, we think some wiki text don't show very well in the preview. Typical minor bug, right? I was the lead developer, right, on this program at the time. So I said, you know what? It's not critical. Actually, it doesn't matter, right? It doesn't seem to me like a showstopper. I have bigger things to solve here, right? The guy says, well, it's actually a problem, blah, blah, blah. I do the typical developer. It's actually not our freaking fault. It's the guys who wrote the wiki text. It's their problem. Can you ask them to fix the content, right? Typical developer, right? Why do we have to care about, stuff that was introduced because they actually, and I even prove why the wiki text was wrongly written, right? And of course, I get turned around and at the time we thought it was one article, right? And then I go, and then basically says, well, actually, we have to fix it. Yeah, long story short, right? When I start looking at it, I realize, okay, I need to figure this out. I run some tests, and I wrote this tool. Now, does this tool look familiar? Right? This is actually a tool that does the similar type of text, but it's actually automating IE. So it's actually open page there, pop-up window, add a table, add columns, set the view, run the stuff, do some browser automation, pop-ups this, gets this, blah, blah, blah. And eventually what it does, it gives me that UI. Does that UI sound familiar? Right? That UI is a UI that allowed me to understand the scale of the problem. The problem was basically, if you load some stuff on the preview and load some stuff on the pop-up, actually they will be different. So think about what the test needs to do. The test needs to load the main UI, needs to load an article on the preview, needs to open the article on a pop-up, needs to grab the HTML of both, needs to find a way to diff them, and now the HTML is a little bit different because they were in place on different locations. Come up with a formula, give your result back. Right? And that has to run automatic. And there's 2,000 or 300 articles. So good luck for doing that thing manually. Right? So basically, I was able to write that, and then I turn around and says, yeah, actually, there's more. It's not just a little thing. Right? And it's funny because we caught in one place. By now, I realize we have to fix this properly. So again, we come around, and we come up with a solution. And then it was all nice and good, except that I keep having this little thing on my script. Every now and then, it was just, because I was coding so fast, it would stop for a bit and go, ooh, it's still hanging there. So when I was cleaning up, I realized my CPU was picking. So I actually gone around, and what I realized, there was one article. Can you guys see that? Look, blah, 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 right? Okay, this is a better picture, right? You can now spot that that's a freaking problem, right? And then there you go, whee, poof, right? So basically, because I had that ability to do that, I was able to then come in here, realize I have a problem, rewrite the script, right, like this. So this is a variation of that script, and now it took me even less, that does this. So this is a variation of the script that runs the whole thing and checks how long it takes to render. And then, because my worry was like, do we have another one of those where it's going to be like 30, 50, 100 articles with a bigger problem? In this case, it happened to be one. I was able to do a fix. There's only one guy that needs to be addressed. We actually put the fix, but we fixed that. And then eventually, I was able to pass the script, and then it worked okay. So in a way, having these capabilities allowed me to actually resolve that. In a way, that's actually a security test. That thing I'm doing there is actually how you fuzz your application. You load the whole thing, you understand the performance. Right? So again, there's a whole bunch of stuff in there on your O2. You can get it from the OWASP website. So if you go there, you can go and you can download it from there. There's the OWASP there. To be honest, there's a mailing list. To be honest, probably your best what's it called, source of stuff is actually my blog. So if you go to my blog, you can see that basically there's about 225 articles about O2. So the best way is when you guys get lost, drop a message to the mailing list. I'll probably answer. Here's an article that explains what you guys are trying to do, and then have a go. So I still think it's a really cool project. I used it literally last week on an engagement where I built exactly that, right, for a project that I was developing. Cool. All right, I think I ran out of time, so thank you.